Hey everyone, I'm Martin from JetBrains. I recently did a private webinar with a customer who asked, what can Rider do for me? That's a very good question, so we decided to publish the demo part of that webinar for everyone to see. We'll not cover all of the features in Rider, but instead we'll focus on the general idea. How can Rider help me be a better and more productive developer? Here goes. This project that you see here is the Nancy project. It's a bit of an older project, but that doesn't really matter for the demo. What matters is it has 39 projects, which is a lot of projects in one solution. And Rider has no issue working with it, navigating through it. So for example, if we search for a Markdown view engine, Rider will quickly find it. We can enter, we can find that thing and navigate around our code base. Even though there are 39 projects, a lot of interdependencies between those projects and so on. So if you would use Visual Studio, I think Nastia mentioned that Rider is a really fast IDE. This is one of the examples where you really see the performance of Rider and where you will see that having those 39 projects poses no problem to the IDE here. Right. A number of people, what they will be doing is coding in Rider. So obviously we have a lot of coding support available. And what I'm going to do here is create a new class in code, basically make it possible to represent a person inside of our code base. So what I'm going to do is add some properties. I want to have an ID for this person. So I want to identify this person by a number. My person will also have a name, which is going to be a string, which means that I can actually put a name in there. And let's say that we also want to have a string called country. And you already see that Rider has those templates that you can use to quickly start typing and writing code. So I didn't have to write this public part. I didn't have to write this getter and setter. All I did was use the prop live template tab, and I can start typing the type that I want to have, for example, an integer again, tab again, give it a name, and so on. So all of those things are in there, and I now created a new class. Now, to create this person in our code base, what I will need is a constructor, basically a method in code that makes it possible to create a new person and use it throughout the application. So typically what you would do in, for example, Visual Studio is you would use a CTOR live templates tab, and you can start adding your integer ID, then you can add your string name, then you can add your string country, and then what you would have to do is set that ID to ID, and set that name to name. And obviously I can do all this in Rider, but Rider is much smarter about the code. And instead of me having to manually write this boring code that is basically all C# language ceremony and not really contributing to the business value of the application that I'm building, what I can do is make use of the CTOR-P live templates that is in Rider. So you will see that Rider recognizes that we have these public properties, which means they have that get and set thing. And I can do a CTOR-P tab, and Rider will generate all of that boilerplate code for me based on what my class currently looks like. So it's really smart, makes it quick. And also, if I start copy-pasting things, there's no chance that I copy the country wrong or assign the name to the country or vice versa. All of this is generated, and Rider uses the same approach for everything, and I don't have to worry about that. This is one approach of doing that. There's another approach where in Rider we can use a shortcut, Alt+Insert, and we can generate code again from here as well. So what I could do is also generate that constructor. Maybe I only want to have that ID and that name assigned when we create a new person. Well, I can select the properties there. I can also add some error checking and then go with OK, and then we'll see something different where we actually do the error checking as well based on the options that we selected here. There's a couple of other things in here that we can generate. So for example, if we want to check if one person equals another person, what we can do is an Alt+Insert, create equality members. And we can say that we want to compare the person by ID and name, for example. So if two persons in my code base have the name Martin, they will all be the same if they also have the same ID. Well, if I now go with OK, you will see that Rider again generates a lot of code for us. We didn't have to type it, which also means that there's no real chance of us making an error in copy-pasting various bits of codes, and really helps us create that quality code, and we can be very sure about the fact that this code is going to be perfect and have no bugs in at least the stuff that they are doing that I didn't manually start entering. Right. Rider also knows about how C# and how .NET, the framework, works. So for example, let's say that I add a new property here, a stream, and I call that photo. Adding a stream of photo means that I can add, for example, an image of this person that I want to use in the application, and I can do that automatically. But there's one downside to that. Stream is a so-called disposable type, which means if my person is no longer required in my running application, I will have to clear out that stream as well, because that stream will hold memory. If we hold memory, then eventually we'll run out of memory. So what we have to do is make sure that when our person is disposed of, when we no longer need it, that we also dispose this photo property that we have. We can do that by implementing the IDisposable interface here. And what you would see in pretty much every IDE is that there's an implement missing members quick fix, and that will do something like this. It basically adds one method signature, and then we have to start thinking about, okay, what do we have to do here? Which property do we have to remove there? How do we go about this? Rider is smarter. Rider actually knows what this IDisposable interface means, and instead of making this implement missing members the default action that we can invoke, there's a generate dispose pattern action. And this one is actually Rider's knowledge coming to your IDE and making it possible to generate that dispose pattern, where Rider will automatically detect that our photo is also disposable. And then we can just go with OK, and Rider will automatically create every part of that code for us, which is really nice because we now have something that actually works. Similarly, if you're more of a front-end person and you're building a Xamarin application, or you're working with WPF or writing a UWP application for Windows, there's an interface called INotifyPropertyChanged. The idea of that interface is that whenever you change something in the UI that you're building, that the value that you enter, for example, in a text box is also reflected in the properties that you have here, and vice versa. If from code we change the name, then we want that name to be visible in our UI. So INotifyPropertyChanged is an interface that does that for us. And most IDEs will again have that implement missing members, where you see this thing. Now what? What do we do? I have no idea. Again, Rider has the knowledge about this interface, so what we can do is implement INotifyPropertyChanged, and you will see that it's, instead of just adding the thing that interface requires, Rider is also adding an onPropertyChanged method, which will make sure that if we set a value somewhere, that it will be reflected in the UI. Now, by doing this, Rider also becomes smarter, because it now knows that this person implements INotifyPropertyChanged. And that essentially means that from now on, we can easily make those name properties and country properties and so on notify the UI whenever they change. And we can do that by alt-entering again and making it a property with change notification. And again, instead of having to write all of this code manually, or even worse, copying that code and pasting wrongly, and for example, if you would do this for the country, forgetting some of those things and introducing bugs, again, Rider generates an entire property for us. It knows that it should call that onPropertyChanged method, and it will inform the UI that something has changed in what we are doing. So this is just one example of writing code and how Rider makes you smarter while you are writing that code. And it's really all about that, making you a better developer, making you faster, and make the code that you write actually better as well and more qualitative. Rider also has excellent inspections for everything you have in code. So this file is riddled with things that are wrong in our code base. So for example, I have an integer here and I'm returning a string. So what Rider will do is give us a notification saying I cannot convert the expression type string to return type int. There's a quick fix there as well, where we can solve the issue that we have in code. There's a bunch of other inspections active in this file as well, but let's not focus too much on those. Just remember, there's about 2,300 or even more inspections in Rider that help you catch errors before you actually put your application in production and things go bad in production. Now, C#, since a couple of versions of the language, has been evolving really fast and really quickly. So another question could be, how do I keep my development team up to speed with everything that is changing in that language? How do I make sure that every developer in the team knows about all of the new features in the C# language? And One of the ways to do that is, again, use Rider, because Rider also has inspections that teach you how to become better at the current language. So if we look at this Nancy C# project that we have here, look at the properties, I am currently using the latest version of C#. Now, I actually wrote this application on C#6, where everything is fine, and everything is the language that we expect. But if we migrate to a newer version of C# in our project, so let's say that latest version that we have here, you will see that a number of things will start appearing in gray. So for example, this get thing here says that there's an inconsistent body style. In C#8, you can actually use expression body properties, and I can Alt+Enter. I can look at that inspection and fix it here. And my code will be updated to the latest C# version. If I have a big code base, what I can also do is make this fix in my entire project or my entire solution even, so that all of these older language constructs are automatically upgraded to the newer version. Another thing is that for a lot of inspections, you will see that use preferred body style is one of those inspections. Rider will also have an entry that says, why is Rider suggesting this? So if you don't trust what Rider gives you out of the box, you can always go to that menu and ask, why is Rider suggesting this? And we will open the web help with essentially a small tutorial on why it matters, what the quick fix means, and what that language property or language feature does for you. So you get all of that out of the box. Now, this is, of course, all inside of one project. There's also solution-wide analysis, where there's a errors in solution tab that we can open, and all of the inspections on your code base will be visible there, and Rider will actually suggest you that, for example, the name engine here is not correct, or in this file there's something else where we don't match a code style rule. So if we want to enforce code style rules, those things will matter as well. Right, let's go to another thing. Let's move on to a number of tools that are integrated in Rider. So in Rider, you will see that all of the tools that you would expect are there. There's a NuGet client where you can bring in third-party packages that you can start working with in your code base. All of that is there. Since Rider is based on IntelliJ and ReSharper, you also get a combination of the two projects or of the two products inside of Rider. So this database view you see on the right is where we can manage our database, where we can open up a database console and start writing queries and even run those queries and get back some output of whatever is in the database. This should work at some point, unless my credentials are no longer correct, which might be the case, but then Rider should tell us. So anyway, imagine there's data coming back and we can actually see what is in that database. This is coming from the IntelliJ side of Rider. Now, a really nice thing is that in Rider, we also really make your IDE the best of both worlds. It's not just IntelliJ and ReSharper, it's really combining the two of them and making sure that whatever we do is actually integrated together and we get the best of both worlds and actually build new features on top of the fact that we have those two worlds. So one example there could be if we are writing C# code and let's say we want to run a query somewhere, let's call it QRI. What will happen is if we start typing a query inside of a string, this will not work in ReSharper, but it will work in Rider because we have a database connection. Rider will suggest me which database tables are there, what I can use, and so on. So I can, for example, select everything from the person table where some condition matches. I can say first name equals Martin, for example, and I get that completion, and Rider makes sure that even though a string, the contents of a string don't really have a meaning inside of in C#, the language, we still get code completion there, and Rider really helps us, again, write better code and be more productive by providing all of those hints that are in there. Nastya also mentions that we have cloud support. I have an Azure example, but there are similar things available for AWS as well. So what Rider does is, for Azure, if you're using Azure Functions, a serverless framework, is it helps you build the applications faster. So typically, if you run an Azure Functions application, you will run all of the functions that are in there. But very often, you're just focusing on writing one of those functions. Well, what Rider will do is add a functions gutter mark here, where we can immediately run just this one specific function. Also, this function is a timer trigger, which basically means that this function will run, in this case, I think every minute. It's really hard to invoke this function while testing. And what a lot of developers do is basically change this thing to run every second. But if they forget to change this back and push this to production, then this thing will indeed run every second in production as well, where that may not be what you want to have. So what Rider does is, instead of having to fiddle with this expression of running every second, is that we also have this gutter mark where we say, okay, you can trigger this function if you want. And in Microsoft Azure documentation, there is a link where there's documentation on how you can trigger, for example, one of those timer triggered functions. Well, Rider knows about this documentation, and we actually have a template there where you can immediately run and invoke this specific function from within the IDE. So again, making you faster, making it easier to work with, and you don't have to read all of the documentation. Rider knows a good deal about the language and several frameworks, and make sure that you can actually use them as well while you are coding your application. And let's cover few more things about making you a better developer. So Nastya mentioned Unity integration, and Unity developers typically use this, the Unity editor, where they work on their 3D scene. They can add objects to that, they can change the camera position and all that. And for the coding part, they can use Rider. So if we go to the Rider view of this specific solution, we will see that we have the Unity assets that we can access, we have the packages from Unity that we can look at, and we have the code. Again, we try to make you a better developer. So for example, what we can see here is that this update function has this little flame icon in front of it. So it means in Unity, it's a game engine, which means that every second, a number of times your screen will be refreshed with whatever the design of your game looks like. What Rider does is inspect the fact, and it knows that this update method is called maybe 30 times, maybe 60 times per second, but it takes time. And since there's no code in there, it actually says, okay, this event function is not really needed. You can just go ahead and remove it if you want. And that is important because we are typically on a mobile device, for example, with games. And if we do 60 times per second calling this function and doing nothing, that's waste. Our battery will drain, the device will get slow, the device will get hot. So that is something that we don't want to do. Some other examples there is, for example, this function is another one that gets called every single frame render. If we compare, for example, that we are working with a current player or the game controller, if we do that using the equals sign here, that is slow. And Rider will actually tell us and say, okay, an explicit string comparison here is inefficient. Use compare tag. So what I can do is Alt+Enter, convert to compare tag, and we're now less performance intensive. And Rider will actually, again, help us make our game better and make sure that we don't drain the battery of whoever is playing the game that we are developing. Not only for Unity, there's another thing that we have in Rider, and that is dynamic program analysis. So I have an application here that is a Sudoku solver. So you can basically enter your entire Sudoku. If you put a 0, it means you don't yet know what is in that position. And if we run this one, you will see that after a couple of seconds, we will get a solved Sudoku, and our application will actually try to fill in the blanks and try to solve this entire Sudoku. Typically it takes around 15 to 16 seconds, and what it essentially does is try all of the combinations that we have in this grid and then come up with a solution of our Sudoku. So that is really nice, except imagine that this is an application that we put in production, and it will show that this application is going to drain server memory, is going to really mess up your production environment. The reason for that is that we are trying all of the combinations. And as you can see, we tried 3.5 million steps in solving this Sudoku, and we are consuming a lot of memory. Typically, you put this in production, developers or IT will see that this application is slowing down your server and then start investigating. What Rider has is a feature called dynamic program analysis, where you can see that there are some common issues in your application. So we can see, for example, that this cell.copy has allocated 3.3 gigabytes of memory in my code base. I can also look at the stack trace where this is coming from in my code, and I can even navigate whatever we have in there. There's another one, this one, cell pop next number. It's only 79 megabytes, but still it's something that might be significant. We can go there and we will see that this is a hot path in code, and Rider is essentially profiling our code before we put it in production. Combine that with the inspections again, and you will see that this thing is allocating some things. It's a delegate allocation, capturing of options variable. What we can do is then Alt-Enter, convert link to code, basically removing that thing from our code base. If we would now run this again, you would see that this specific issue in our code base no longer shows up, and Rider actually made our code better, and we didn't even have to write all this. Rider essentially gave us a solution as to how to make this better. We can already see that it's probably going to end up faster than the previous run. So yes, this only took 13 seconds. And if we now look at our dynamic program analysis, you will see that our function call is gone, and there's actually a number of problems that have been removed by changing this bit of the code base. So I would say in summary, Rider is really about making developers better by educating them, by trapping issues that are in a code base that will typically only show up in production. Rider will try to catch those at development time. And as a result of that, you will have better quality applications, better quality code, and a developer who is educated about what the language supports there.